Okay, in this problem, we need to solve the system of equations by elimination or addition. Give your solution as an ordered pair. So in this one, we want to get the numbers in front of either the x's to be the same but opposite or the y's the same but opposite. Okay, the first thing I would do though is I'm looking at this fraction equation and I would multiply by the denominators just to get this to get rid of the fractions. So let's multiply everything here by 3. Now make sure we have to multiply every single term to keep this equation balanced. So the 3's are going to cancel there, so I get 2x. The 3's cancel there, and I get 2y equals 2 times 3, which is 6. Now if this feels too confusing to just distribute like that, I would just write like 3 over 1, so you can cancel it, and then 3 over 1, and then another 3. And you probably would want to write it out so you have a little more space. Okay, so we have that bottom equation. It looks much nicer now. And then we have 4x minus 2y equals 6. And so at this point, we want to add these two equations together because notice the y's are the same but opposite. I have a negative 2y and a positive 2y. So when I add those together, those are going to cancel and I'm going to be left with 0. 4x plus 2x gives me 6x. I can write plus 0, but I'm not going to. Equals 6 plus 6, or 12. Divide by 6 on both sides, so I get x equals 2. And now I need to solve for y. So I can substitute this 2 into either equation, either one of these first two, or even this one right here. But I'm going to just go ahead and do it into the 4x minus 2y. So 4x minus 2y equals 6. So I have 8 minus 2y equals 6. I'll minus 8 on each side. So those cancel. I'm left with negative 2y equals negative 2. Divide by negative 2 on both sides, and y equals 1. So my final answer then is 2 for x. Oops. I wrote a negative 1, but it's a positive 1. So 2, 1. Now if you're unsure about your answers, you can always substitute them in and make sure they make the equation come out true. And they will always come out true if it's a correct solution in both equations. If you're feeling confused on any of this, reach out, and if not, watch the next video.